Bekaert Specialty Films, world leader in the development and manufacturing of high-quality window film products for architectural, automotive, specialty, and safety applications. This certified test was done in accordance with Miami-Dade Protocol PA201 and PA203 and SSTD 12-99 for exterior glazed opening systems. 3 identical test specimens consisting of 3/16 tempered glass coated with 8mm clear safety film attached to the commercial frames using Dow Corning 995 sealant were used. Each specimen was impacted 3 times, once within a 10-inch radius in the center, once within 11 inches from the side, and once within 11 inches from a corner. Each impact consisted of 10 spherical steel balls, 8 millimeters in size, impacting specimens at a speed of 130 feet per second. This is the center impact. Glass broke, but no penetration occurred. This is the side impact. Glass broke further, however, no penetration occurred. This is the corner impact. Glass once again broke further, but no penetration occurred. These specimens were structurally intact with all parts securely in place at the conclusion of each test. This certified test was done in accordance with SSTD 12-99 for up to 100 miles per hour wind speed for exterior glazed opening systems. 3 identical test specimens consisting of 3/16 tempered glass coated with 8mm clear safety film attached to sliding door frames using Dow Corning 995 sealant were used. Each specimen was impacted 2 times, once within a 2.5-inch radius of the center and once within a 6-inch radius of the corner. Each impact consisted of a 4-pound No. 1 Southern Yellow Pine S4S 2x4 missile, 46 inches in length, traveling at a speed of 40 feet per second. This is the center impact. Glass broke, but no penetration occurred. This is the corner impact. As you can see, because of the location of the impact is very severe. However, the missile was rejected and no penetration occurred, even though the glass was previously broken by the center impact and further broken by the corner impact. The glass remained in the frame. These specimens were structurally intact with all parts securely in place at the conclusion of each test. This test simulates wind load and pressure during hurricane conditions. This test is conducted after impact testing has occurred on both the small missile impact and the large 4-pound missile impact specimens, after their respective tests were successfully completed. Design loads varied from plus 70 to minus 75 pounds per square foot on the small missile impact test. On the large missile impact test, design loads varied from plus or minus 50 to as high as plus or minus 80 pounds per square foot. This test duration is 9,000 cycles, each cycle being 3 to 5 seconds in length. After 4,500 cycles, the test specimens are rotated to pressure the window in the opposite direction, another 4,500 cycles. This test is over 2 hours in duration. As you can see, a tremendous amount of pressure is being put on these windows. The pressure is forcing broken glass to be pushed against the safety film for a long period of time. The amount of pressure on the entire glazing system is very evident in the frames actually flexing, as viewed on the specimen on the right side. These specimens were structurally intact with all parts securely in place at the conclusion of each test. This demonstration shows what will occur when a large 9-pound 2x4 traveling at a speed of 50 feet per second impacts a commercial window with 3/8 tempered glass. This is commonly referred to as the Dade County Large Missile Impact. This was done for demonstration purposes only. As you can see, the missile went right through the glass, knocking a rather large hole in the window, therefore allowing wind and rain to enter the interior of a building. As you can see, once pressure is applied to untreated broken glass, the integrity of the window is destroyed. Imagine what could occur during a storm. We will now repeat the previous demonstration with an identical window coated with 14mm clear safety film attached to a frame with 995 Dow Corning sealant. This is for demonstration purposes only. As you can see, the glass broke. Even a small hole was put in the window by the severe impact. However, the missile did not fly through the window, and the rest of the glass stayed relatively intact. How relative is large missile impact? A major study by Applied Research Associates Incorporated, which was funded by the insurance industry, recently stated that protection from windborne debris and strong hurricane winds is clearly needed for houses in residential suburban developments. However, the strongest conclusion that can be drawn from this study is that large missile protection for peak wind speeds less than 110 miles per hour does not seem warranted. The probabilities of large missile impacts on windows for a typical house is less than 5%. The glass treated with the safety film remains intact after pressure is applied. The safety film with the sealant attachment system is holding the broken fragments in place and in the frame. During a storm, this would provide greater protection than any untreated glass. Actual windows in a home or building may vary in performance from the windows tested due to various glazing components. Bekaert manufactured safety films are presently on buildings around the world, protecting their glass against violent weather as well as mitigating injury from terrorist acts such as bomb blasts and other acts of violence. Bekaert safety films, sold under trademarks ArmourGuard and ArmourCoat, are backed by a limited manufacturer's warranty. Bekaert is the leading manufacturer of safety films, and our products are backed by a strong company, in existence over 100 years with over 17,000 employees. Certified test results, as mentioned in this technical video, are available upon request.